I'm out of coffee. I don't have any coffee. Ah, whatever. Day 2. No, Unit 2, Day 6. Oh my God, I'm so excited. Day 6. After Day 6 comes review. And then the test. Oh my God, things are getting so exciting around here. I'm so excited. These aren't tears of joy, tears of cryingness. These are tears of joy. Mr. Key is back to help you out. Actually, that would be Mr. Krause. By the way, if you're looking for my videos, they're all on www.mrkraussemath.com. www.mrkraussemath.com. All one word. Hit the subscribe button. Subscribe to me. If you're watching my videos and I'm helping you out, you can help me out by hitting the subscribe button. If you like any of the ads that come on, sorry about those, but I'm trying to make a little extra money. If you watched any of my videos, you know my stuff's running out. Look at the pens and my pen tips just going. My computer's going. Everything's going. Eventually, I'm going to need a new computer. There's a donate button up there. If you want to hit the donate button, you can help me out with that too. Otherwise, stay here, watch the video, steal everything I got, take me for everything. Okay, let's get started. Enough of that. So anyway, we're going to solve absolute value functions. Did I ruin it? Okay, so don't forget, isolate the weird thing, get the weird thing alone. X minus 4 is equal to 3. Split it up into 2 problems. X minus 4 equals 3 and x minus 4 equals negative 3. Solve them. X equals 7. X equals 1. Check them. 7 minus 4 is 3. Yes. 1 minus 4 is absolute value of negative 3, which is 3. Yes, done. Check. Okay. Nice. Check your answers. In order to get rid of a square, we take the square root. But you got to remember, when you take the square root, you got to put a plus or minus. So this is really x plus 2 equals plus or minus the square root of 6. And then just solve it by moving that thing over. We're going to come to this particular idea later on, and we're going to see a lot more of this. So this is just a little foreshadowing, like English class, a little foreshadowing of some fun things to come. Oh yeah, math is fun. It's like 11 o'clock. No, it's what time is it? Oh, it's only 8 o'clock. I feel like it's 11. I'm so tired. This is like my 4th video today. I just wrote 6 letters of recommendations today, or finished 6 of them. Oh my God, it's getting crazy. All right, here we go. Let's talk about inverse operations. This should be very easy. The inverse operation of addition is, of course, subtraction. The inverse operation of multiplication is, of course, division. The inverse operation of something that's squared is square root. The inverse operation that's something that's a square root is square it, or squared. The inverse of something that's being cubed is cube root. And the inverse of operation of something that's a cube root is to cube it. These should be obvious. Cube it. Cube it. All right, so here we go. We're going to get to work. Basic steps. Isolate the weird thing. Undo the weird thing. Solve for x. Check for extraneous solutions. Bogus answers. Crapola. All right, kiddies, let's go. All right, so in order to get rid of a square root, by the way, have the weird thing alone. That's great. We got the weird thing alone. All right. Now we're going to undo the weird thing. And in order, what happened? Why is Cortana showing up? Go away. In order to get rid of a radical, in order to get rid of a square root, you got to square both sides. So what we're going to do is square both sides, because a square and a square root undo each other. They're inverse operations. So I get x minus 5 equals 16. All right, solve for x. X equals 21 by adding 5 to both sides. Check your answers, please. Sometimes they get bogus answers, otherwise known as extraneous solutions. 21 minus 5. That's the square root of 16. Ka-ching, check. Didn't take long, did it? Huh? Lazy bum. Check your freaking work, man. You're making me mad. Yeah, you. No, you. That one. No, the one over there. No, not you. Oh, whatever. Let's go. Weird thing's not alone. There's the weird thing. I got to get it alone. So what I'll do is I'll move the 2 2 over. So I get x plus 3 equals 4 by subtracting 2. Now the weird thing alone looks a lot like that other problem, doesn't it? We're going to square both sides by undoing the weird thing. Inverse operation of the weird thing. We get x plus 3 equals 16 or x equals 13. Check your answers, please. Plug it back in. We're going to take the square root of 13 plus 3 plus 2. We want to make sure that this is equal to 6. Well, this is the square root of 16 plus 2 or 4 plus 2. Ka-ching! Here we go. Now, we got to get the weird thing alone. Now, these things are being multiplied. What's the inverse operation of multiplication? Division. So we're going to divide by 3 and divide by 3. And I get, oh my gosh, look at this. It's going to look a lot like the last couple of problems we've been doing. X minus 4 equals 4. Wow, doesn't this look familiar? So these are just 3 different examples of how I could do basically the same problem. 1, I give it to you already with the weird thing alone. 2, or 3, I give it to you the weird thing alone. 4, I give it to you with something you need to move over by adding and subtracting. Or 4, I give you something where you have to divide. Or 5. And I get x minus 4 equals 16 or x equals 20. And in order to save some time, it works. Now, don't you be this lazy. I'm not being lazy. I just told you it worked because I already checked it. But I'm telling you it works. So don't call me lazy. And don't call me baby either. And don't call me late for dinner. And don't call me bald. That really makes me mad and sad. Now they're getting harder. We have a binomial on the left side, so we got to do some really crazy work. Now, this is a binomial, otherwise known as a binomial. It's got 2 terms. So what we need to do, because we're going to square it, is put it in parentheses. Well, x plus 1 squared is really x plus 1 times x plus 1, which is really x squared plus x plus x plus 1. Don't forget to double distribute, not just your lazy garbage, double distribute. So this is really x squared plus 2x plus 1 equals 7x plus 15. Now, we need to, it's a quadratic, so we have to solve it and set it equal to 0. First, we're going to set it equal to 0, and then we're going to solve it. So we're going to move everything to the left. Why does my pen keep going away? X squared minus 5x minus 15 minus 5x. Oh, I forgot the plus 1. No, minus 14. There you go. I forgot that 1. That makes a huge difference because it wasn't going to factor. So now it factors to x minus 7 and x plus 2 equals 0. So I get 2 answers. X equals 7 and x equals negative 2. Check your answers. I'm going to need some room because I got 2 checks to do. So I'm just going to get rid of this crazy work. I would have done that in my head anyway. So I'm going to check these, because sometimes you get what's called extraneous solutions. So let's check 7. 7 plus 1, does that equal the square root of 7 times 7 plus 15? Well, this is 8 equals the square root of 64. And I think you can check and see that works. Now we're going to do negative 2 plus 1. Does that equal 7 times negative 2 plus 15? Well, this is negative 1, and that's a little strange because you really can't take the square root of something and get it negative without a negative being in the front, so it's a little weird. But this is really just the square root of 1, and this is the square root of 1, which is 1, does not equal. So this answer is an extraneous solution, and sometimes when you use a method to solve an equation, you get bogus answers, and you got to eliminate those. All right. Now we're going to do a little bit of combinations of things, and we're going to play around with some things, and we're going to make things harder. So the first thing we're going to do is add 4 to bring it over. So I get 2 square roots of x plus 3 equals 12. Then I have to get the x plus 3, the weird thing alone. And remember, this is the weird thing. We've got to get it alone. So I get square root of x plus 3 equals 6. Now I'm going to square both sides. That's the undoing or the inverse operation of radical. And you get x plus 3 is equal to 36. Or x equals, 33. Perfect. And it checks. I'm not going through it. This one I'll probably go through. This one we have a cube root. in order to get rid of a cube root, you have to cube both sides. Remember, the opposite operation, the inverse operation of cube root is to cube it. So we're going to cube it. So when I cube and a cube root, they just undo each other or cancel each other. So we get 7x plus 7 is equal to 27. 2x is equal to 20, or x is equal to 10. We want to check our answer. So we're going to take the cube root of 2 times 10 plus 7, and I'm hoping that's 3. Well, this is the cube root of 27, and by now you should know the cube root of 27 is 3. So that checks. We're going to bring this 9 over, so we take the cube root of x is equal to 8. Now, in order to get rid of the cube root, I'm going to cube this side, and I'm going to cube this side, and I get x is equal to, and 8 cubed is 512. I'm going to check my answer. Let me go back to red, check my answer. And I go the cube root of 512 minus 9, does that equal negative 1? Well, this is 8 minus 9 equals negative 1. Negative 1, check. Isolate the weird thing. You get the cube root. Don't forget the cube. It makes a huge difference. X minus 3 is equal to 2 because we divided both sides by 2. Cube both sides. Cube. Remember, if I'm going too fast, buffering, pause. Cube both sides. Pause the class, pause the video, slow it down, rewind it, go back, see what I said. I know I talk fast. I know this is going quickly, but that's the beauty of the pause button. Go back, listen to it, try it. Go back, listen to it, try it. Back. That was a movie. I don't know what that was from. So I cube root of a cube, and that just cancels each other out. So I get x minus 3 is equal to 8, because 2 cubed is 8, or x equals 11. Let's check it out. I'm going to do a little check over here. So we get 2, and don't stop now because the next page is really difficult. So we get 2 cube roots of 11 minus 3. Does that equal 4? Well, this is 2 cube roots of 8. Does that equal 4? The cube root of 8 is 2. Yes, it works. And now comes the really hard stuff. So you have radicals on both sides. So you want to make sure you have one radical per side. You want to square both sides. Woo, lots and lots and lots of math. That's the hard part. And then get one radical alone again, and then start over. So basically, here is the stuff we already just did. Here, this stuff is the new stuff that we're going to do, okay? So, we have a radical on both sides. But in this case, we have a binomial on the right. So, in order to get rid of it, we're going to square both sides. Now, in this case, if I square the right side, let me throw this in a little parentheses. It really means 3 minus the square root of x times 3 minus the square root of x. On the left side, it's easy. It's just x plus 4. On the right side, though, we have to double distribute. So I get 9. 3 times 3 is 9. Minus 3 square roots of x. Minus 3 square roots of x. Now, negative x square root of x times negative square root of x is positive x. Now, what was the next step? Algebra, and get the radical alone. So, x plus 4 is equal to 9 plus x minus 6 square roots of x. I do not like the fact that this thing is all by itself. So, I'm going to move this. Well, that doesn't really matter. These x's will cancel. I'm actually going to move this over here and put 5 on this side. And I'm going to move this over to the other side because I don't like it being negative. That bothers me. I don't like having things being negative that I'm solving for. So I get 6 square roots of x. You have to get the weird thing alone. So we're going to divide by 6. Divide by 6. So I get the square root of x is equal to 5 over 6. Still solving for x. Now we got the weird thing alone. Now I want to solve for x. So in order to get x by itself, you have to square both sides. So I'm going to square this side. Square, square, come on. Square the left side and square the right side. Well, when you square a fraction, you just square the numerator and you square the denominator. So my answer is x equals 25 over 36. Man. Now we got to check that. So I'm going to check that using the calculator because I think that's the easiest way. So I go to my calculator and I say, okay, let me get rid of all this. Clear history. So I'm going to do 25 divided by 36, and I'm going to stow that into x. You'll notice it'll fix it for me, make it look nice. And the left side is the square root of x plus 4. So somewhere, the square root I don't know why it doesn't like that. So the square root of x plus 4. Probably a crazy answer, 13 over 6. And then I'm going to do 3 minus the square root of x. 3 minus the square root of x. And hopefully I get the same answer. There it is. I checked it. It worked. I know that's a weird answer, but there it is. That's your weird answer. What the heck? All right, you heard the directions. Direction 1, radical on both sides. So that's our first direction. We're going to move this over here and make it minus radical x plus 5. So now I have radical x minus 3 equals 4 minus radical x plus 5. Next step, square both sides. This is a binomial. It's going to require some work. So on the left side, it's easy. We just square it. The square root and the square cancel. We're happy about that. We get x minus 3. This side, though, we have to, remember, we're squaring it, which means we're really just multiplying it by itself. 4 minus radical x plus 5. So 4 times 4 is 16, minus 4 square roots of x plus 5, minus 4 square roots of x plus 5. And then I multiply negative radical x plus 5 times negative radical x plus 5. I just get positive x plus 5. Now I'm going to do some algebra. This x is going to cancel with this x. And I get negative 3 is equal to 21 minus 8 square roots of x plus 5. I hate having that negative, so I'm going to move that over here. 8 radical x plus 5 is equal to 24. That's making it look nicer. Divide. Now, isolate the weird thing, get the weird thing alone. Now, this is like a beginning problem. Isolate the weird thing. I get radical x plus 5 equals 3. Get rid of undo the radical by squaring both sides. Square both sides, square both sides. I get x plus 5 equals 9 or x equals 4. Did I get that right? Yay! And this check is actually rather simple. I don't necessarily need my calculator because it's not some crazy answer like it, but I just want to see what I got here. So it's not some crazy answer like I got before. So let me check it using this black. So check. The square root of 4 minus 3 plus the square root of 4 plus 5, does that equal 4? Well, this is the square root of 1, which is 1, plus the square root of 9, which is 3, and yes, of course, that equals 4, so that checks. Not a bad check there. All right, this one right here. Get a radical on each side, so we're going to get radical 2x minus 5 is equal to negative square root of x plus 6. Now, when you square something, don't forget it becomes positive. So if I square it and I square it, I get 2x minus 5 is equal to x plus 6. Now I just have to solve that. Well, don't forget it's really times negative radical x plus 6. So the negative times negative makes it positive. That's why it's positive x plus 6. So this gives me x equals 11. So now I got to check my answer. So is 2 times 11 minus 5 plus the square root of 11 plus 6. Does that equal 0? Well, this is the square root of 27. Nope. I don't know why I just did that. This is the square root of, let's see, 22. That's the square root of 17 plus the square root of 17. Does that equal 0? No, that's 2 square roots of 17. That does not equal 0. So here, my answer is l'empty set. All right, kids, last one. And just so you know, it's a lot of work. We're going to go slow. Lots and stuff. So I give you a whole page on this problem. Woo! Man, is this a beast of a problem. This would be like bonus, I think. It's a crazy problem. We like to call this the crazy problem. I don't know why. Because we're crazy. So let's see. We're going to already got a radical on both sides. I don't want that there because I gotta have a clean sheet of paper. So I already have a radical on both sides. Let's use blue for its happy colors. And we're going to square both sides. Square this. Last problem of the day, though. Last problem of the day. Which means we got to double distribute here. Square root of 5x plus 6 minus 3. On the left side, we just get x plus 3. On the right side, we're going to get these two multiplied together, give me 5x plus 6 minus 3 square roots of 5x plus 6 minus 3 square roots of 5x plus 6 plus 9. All right, we got a crap load of algebra to do. Let's clean things up on both sides first. X plus 3 is equal to 5x plus 15 minus 6 square roots of 5x plus 6. Now I'm going to move this over to the other side because I don't like it. Remember, we've got to isolate the radical, and I don't like my stuff negative that I'm going to isolate. So I'm going to bring it over here, and it becomes positive. Positive 6 radical 5x plus 6 is equal to, now I'm going to subtract x and subtract 3, equals 4x plus 12. Now it's going to start getting a little bit worse. Now you got to isolate the weird things, so we got to divide by 6. So what I have here is radical 5x plus 6. Oops, I don't know why. I need that parenthesis for later. Is equal to 4x plus 12 over 6. Now I can simplify that if I want to, but I'll just leave it the way it is. Now what do? Well, I got to get rid of the radical by squaring both sides, which means to square this, I just really means I'm going to multiply it times itself. I say we do a little bit differently. So let me see what we get here. We'll use black. We'll go 5x plus 6. And I'm going to put this over 1. You'll see why in a minute. Is equal to. Now, this is really 4x plus 12 squared. So that's 4x plus 12. So that's 16x squared plus 48x plus 48x plus 144. I just double distributed out. So that's 16x squared plus 96x plus 144 all over 36. Maybe I should have simplified it. Now you can see why I put it over 1, because we're going to cross multiply. So I get 16x squared plus 96x plus 144 equals 36 times 5 is 180. So 180x plus 216, because 6 times 36 is 216. My x squared's positive, so everything's got, yeah, we got a fact in this puppy. Oh yeah, I told you it was going to be fun, didn't I? So we're going to do 16, oh, there we go, 16x squared. Now, 96 minus 180 is negative 84. I just want to make sure I got that right. X minus 72 equals 0. Because I just subtracted these two. I just brought these two over to that side. I think I can take a 4 out. That'll make things a little bit easier. 4x squared minus 21x minus 18 equals 0. I guess let's try 2x and 2x first. So 2x and 2x. Now multiples of 18 are 1 and 18, but I can't put the 18 in either place. 2 and 9, but I can't put the 2 in either place. Or 3 and 6, and I can't put the 6 in either place. So starting with 2 and 2 didn't even make any sense because I can't use any of these numbers. So let's try 4 and 1. So 4x, and x. I'm going to try 3 and 6. I think that makes sense. Let's put the 6 here and the 3 here, because the 6 couldn't go with the 4 anyway. This is 24, and this is 3, and that makes 21. So we want negative, so that's negative, and that's positive. So this is not going to yield a solution. If there was an x out there, it would give me the answer 0, but it doesn't. This one gives me 4x plus 3 is equal to 0. Bring the 3 over and divide by 4, and I get x equals negative 3 over 4. This one is just x equals 6. Those are my two answers. One of them doesn't work. I'm going to tell you that right now. So what we're going to do is we're going to check them in our original. So I'm going to bring them up here, negative 3/4 and 6. So negative 3 over 4 and 6. But one of them we're going to eliminate. So let's see. I'm going to go back and look at my original problem. So I'm going to erase the work that I put on it just to see what's there. And grab black. And I'm going to go to my calculator. Use my mouse now. Negative 3/4. So negative 3 divided by 4. Now, if you remember, if we didn't have this calculator, what you'd be doing, it'd be a lot of work. You really would be going crazy checking this answer. And we probably wouldn't make one this difficult. But now that you have the calculator, you have the technology, you can do that. Square root of x plus 3. The square root of x plus 3. 3 halves. 5x plus 6. So square root of 5. Actually, I think maybe both don't work in this case. Plus 6. Out of it, minus 3. Oh, so close and yet so far. So we got rid of one solution. Let's see if we can get rid of the other. Maybe this is an empty set. Maybe there are no solutions. So let's try this one. Now the cool thing is, now that I've tried one, the next part's easy. So 6 stow x, that's the hard part, enter. And we just go up here and we highlight that first equation and press enter, 3. And we go up here, highlight that second equation, make sure, oh, and they're equal. So yeah, by the way, if you get both solutions, if you get two solutions, generally one of them will be extraneous and one of them will be good. If they both don't work, you probably did something wrong. That's it, kids. Solving, those are tough. Those are tough. We're going to struggle with those in class. We're going to have fun with those. Fun like in, yeah, F-U, fun, Krause. I know what you're saying. I know what you're saying. You're saying fun starts with F-U. You were swearing? Oh, man, that's very hurtful. Hit the subscribe button. Go to MrKrauseMath.com. You can hit some of my ads, too. That gives a little money my way. If you don't have any money to donate, you can hit my ads, too. Hit the subscribe button. Hit the like button. Comment. Email me. Find out if you got any questions. Let me know. Rewind the video. Check your solutions. Nice job today, kids. I'm glad you stuck with it. Peace out. It's been fun having you here.